Good afternoon, everyone. Welcome back. Thank you for joining us. We're glad that you're here. I'm Steve.
And I'm Scott.
And together we're Backyard Musings, the Science and Technology channel.
Yeah, we're talking today about our favorite telescope, the James Webb Space Telescope, and what it's seeing out there. So we like this story.
We might have found where
Bigfoot.
Anakin Skywalker lost his leg and his arm. We might have found it.
Oh, okay.
Might have found it. Okay, the James Webb Space Telescope data suggests 55 CNC. So it's the star 55 CNC E, meaning the fifth planet, A, B, C, D, E, fifth planet, may be a hydrogen-rich lava world with an atmosphere tied to its molten interior. It is so we're giving you a fantasy narrative here. It is the year 2158, and
we're passing on information of somebody giving you a fantasy information.
Yeah.
Okay.
It's the year 2158, and you're working on a PhD in planetary volcanology at the University of Utopia Planitia on Mars. Pretty bold. Graduate students are still paid less than they need to live on, so freeze-dried ramen has been your main food for the past 3 years. After finishing, go ahead, Scott.
Okay. After finishing your study of Jupiter's moon, Io, you now need to look beyond the solar system for a strong exoplanet comparison. Io's volcanic activity comes from tidal heating, but your project requires a world where volcanism is driven by intense heat from its host star.
You have recently secured funding from the Exoplanet Research Institute for a faster-than-light ship, with one requirement: the target exoplanet must be less than 50 light years away.
In the present day, scientists have used NASA's James Webb Telescope to study 55 what are you calling this?
CNCE.
CANCRIE, right? Or 55 CNCE. Okay. A super Earth with a radius of about 1.9 times that of Earth and a mass of about 8 times larger. The planet is roughly 41 light years away, is locked to a sun-like star, and completes an orbit in about, not quite, a little over half a day. Would you like to know more? Really? That's your line.
Here we go.
Okay.
Scientists.
That was all your input. Got it. Okay. Now I'm on board now. Okay.
So yeah, that was a little fantasy thing. You're a PhD in 2158. Now you got to do a study of this planet. Okay.
Okay.
Scientists think this extremely tight orbit may be hot enough to melt the planet's surface. For comparison, Mercury takes 88 days to orbit our sun. The findings were recently submitted to Nature Astronomy on June 10th of this year and may help scientists better understand how lava exoplanets form and change over time.
Using the James Webb Space Telescope, the scientists observed 5 eclipses of 55 CNCE and compare the results with long-standing models of the exoplanet formation and evolution. Those models suggest that lava planets should contain high levels of carbon monoxide and carbon dioxide.
The scientists concluded that the atmosphere of 55 CNCE is likely made up of large amounts of carbon monoxide, smaller amounts of carbon dioxide, and abundant hydrogen. They also noted that differences across the 5 eclipses could point to outgassing or to clouds produced by that outgassing. These clouds could briefly cool the surface before fresh outgassing clears them away.
The study notes, quote, since secondary atmospheres of rocky planets are set by the composition of the interior and subsequent outgassing, I know some people like that. The composition of their atmospheres is directly linked to their interior redox. Is that redux? Redox states. I don't know what that means. What does that mean? You have any idea? Okay.
If you know, tell us in the comments.
Okay. The preference for hydrogen-rich models, together with the steep inversions they produce, therefore suggests an interior with relatively low oxygen fugacity, consistency, consistent with outgassing from a reduced magma ocean, unquote.
For context, a planet's redox state is the chemical balance between oxygen and hydrogen iron within its interior. In the context of 55 CNCE, hydrogen is heavily favored compared to oxygen, resulting in the exoplanet's hydrogen-rich atmosphere.
Lava exoplanets have come into the spotlight in recent years, as several have been discovered within the last decade, with 55 CNCE being discovered in 2004. These exoplanets include K2-141b as in boy.
We've talked about that one, Scott.
We have. I think we have, yeah. L9859d as in David. TOI-561b. HD63433d. And COROT-7b, which have orbital periods of about little over 6.5 hours, 7.5 days, 10.5 hours, a little over 4 days, and 20.4 hours, respectively. Like 55 CNCE, all these exoplanets are tidally locked to their host stars and experience extreme temperatures. While 55 CNCE has its lava on the sun-facing side, exoplanets like L9859d have its entire surface covered in a magma ocean like Jupiter's moon Io.
Okay, so remember, tidally locked, we talked about this with Saturn and Titan. That means that the
no rotation.
In this case, the planet is locked going around the sun. It doesn't rotate like the Earth does. It's locked. One side faces its sun and the other side doesn't.
Never. Yep.
Never. Yeah. As noted in the fictionalized tale we opened with, the volcanism on Jupiter's moon Io is caused by tidal heating, which occurs from the small moon being stretched and compressed by Jupiter's immense gravity. In contrast, all lava exoplanets listed above, including 55 CNCE, are the result of the extreme temperatures they endure while orbiting at extremely close distances to the host stars. So we said, so this is 55, I'm going to take a pause here. 55 CNCE, that's the fifth planet. Don't think, because the fifth planet in our system is Jupiter. You got Mercury, Venus, Earth, Mars, then Jupiter, right? So don't think that this planet is so far out like Jupiter. This planet is close enough to get superheated, but it's the fifth planet, okay? Okay. So including 55 CNCE are the result of the extreme temperatures they endure while orbiting at extremely close distances to their host stars. While Io has volcanism all over its surface, some lava exoplanets have their lava surfaces on the sun-facing side due to them being tidally locked. Okay.
Okay, quite a find.
This might be Mustafar, where Anakin or Darth Vader lost his legs and arm. Never know.
And all discovered by the James Webb Space Telescope.
Our favorite.
Yep, definitely our favorite. So, all right,
folks. Thanks for joining us. We'll catch you in the morning.
We'll see you tomorrow morning. Take care. Thank you.